Welcome to Spreadsheet Geek. In this video, we'll compare Excel's solver to an add-in that can perform a Monte Carlo simulation. By the end of the video, you should understand what a Monte Carlo simulation can do that Excel's solver can't. This video was made using Microsoft Excel 2019. The way I'm going to illustrate the difference between solver and a Monte Carlo simulation is through a problem. Here's our problem. We run a fruit stand during the summer months only, and we have to place an order for all of our fruit at the beginning of the summer season. We have this probability data to help us make that decision, and this is based on previous seasons. Based on those previous seasons, we believe there is a 15% probability that customer demand for fruit at our fruit stand will fall between 1,500 and 2,000 kilograms. If that is the case and we want to go forth with that assumption, we would order 2,000 kilograms. We will always order an amount of fruit that is at the top end of each of these ranges. If we believe that 2,000 to 2,500 kilograms is the appropriate range for this season, we can see that that's happened about 20% of the time in past seasons. We will buy our fruit at $2 per kilogram. We will always sell it at $6 a kilogram. If it's close to spoiling, we can sell it to a local farm for 20 cents a kilogram. These are the givens of the problem. This is a good problem for a Monte Carlo simulation. We have a random variable, that random variable being customer demand. If I were to insert a quick bar chart here, you can see that the distribution of outcomes for demand is fairly normal. It's a little skewed, but we need to look at the highest probability possibilities and try to maximize our profit. It is our primary goal to maximize the profit, but it is also our goal to minimize the risk. We don't want to buy thousands of kilograms of fruit at $2 a kilogram and only to sell it back to that farm at 20 cents or 1/10 of what we paid for it. To solve this problem, I'm going to use some random numbers. If you type into any cell equals RAND, open parentheses, close parentheses, you can get a random number between 0 and 1. I'm going to take that down to 2 decimal places. So just by hitting the F9 key repeatedly, I'm getting random numbers between 0 and 1. So that's how that works. What I want to do is have this cell for my produce ordered read this random number and come up with an order level that's one of these numbers up here. So let's go ahead and do that. I've set up a little VLOOKUP table here, and these probabilities are copied directly down from here. These are just numbers in a cell. And likewise, these order numbers are just numbers in a cell, and I took the high end of each bin here and filled it in over here. So what I'm going to do here is generate a random number between 0 and 1 here. This cell here is going to read that number, and it's going to go over to this lookup table and generate an order quantity to report back to this cell. So in order to do that, I'm going to have to set the minimum and maximum bins here, and you'll understand why later. This one's going to be 0 to 0.15. And let's express all of these as 2 decimal places. So this minimum bin here is going to equal this value, and it's going to go up to 35. So this cell will equal this plus this. And so on down the line, we should get to 100. Good. So The reason I had to do that is because we're going to use a feature of the VLOOKUP function that I don't use very often, which is the approximate match. Let's fill in this cell with our VLOOKUP formula. We're going to look up this value in this table array, and I'm only going to highlight the last 3 columns. And we're going to return what's in column 3. And this is where we're going to enter true. Normally I would enter false for an exact match, but we're going to accept an approximate match because we're going to use the range. The approximate match function of a VLOOKUP doesn't work very well in my experience with words, but it does work extremely well with numbers if you use it like this. For example, 0.75, what Excel's going to do with this VLOOKUP formula here is look up in this table array down column E, and it's going to go to the first value that exceeds 0.75, which would be this one, and then it's going to drop back to the previous one. So we have a range of numbers here in which 0.75 falls in the middle. So that's why it's returning 3,500. And if I were to hit the F9 key again, now I've got 0.24. It falls between this range, so the return should be 2,500, which it is. So that's our random number generator being used to just randomly generate an order amount. Let's move on to demand. I've set up another random number generator. It'll generate a number between 0 and 1 all day long after you hit the F9 key. And produce demand is going to fill in this cell based upon what it reads in here in part. Now, for the produce demand, we don't think it's ever going to be less than 1,500 kilograms, and we don't think it's ever going to be more than 4,500 kilograms. So those are the outer limits of what number should appear here. There is another caveat on what number appears in this cell, in that this demand, it really should say produce sold. In fact, I'm going to change that to produce sold. The produce we sell can never exceed the produce we ordered. So that's another constraint on this number. Let's enter an if function here. And we'll say if 1,500 plus this random number times the excess that could possibly occur above 1,500, which is 3,000, if that is greater than whatever number appears here for what we ordered, then what we sell will be what we ordered. If that is not true, then the answer will be 1,500 plus this random number times 3,000. We'll close that formula off. So now if I hit the F9 key repeatedly, I should always see up in this cell one of our order amounts, one of these 6. And down here I should see a number that never exceeds this, but may be less than this. So let's see if this is working. And it appears that that is working. There's one that's a little bit less, same. So it looks like our random number generators are working. So now we just have to calculate our profit. Our sales revenue will be equal to however many kilograms we sold times the $6 sale price. Our cost of goods will be equal to however many kilograms we ordered times our unit cost of $2. Our disposal revenue is either going to be 0 or some positive number. It'll be 0 if we sold everything we ordered, and it'll be some positive number if we over-ordered. Let's enter an if statement. if we ordered more than we sold, then this should equal what we ordered minus what we sold times the rate of disposal. Otherwise, it will equal 0. Now I can see that I made a mistake here because this needs to be negative, this cost. So let's fix that. And we just went to one where we ordered more than we sold, and it's generating a little bit of disposal revenue. Let's hit the F9 key to cycle through to one where we ordered as much as we sold, so there is no disposal revenue. So that looks to be acting correctly. I'd like to hit this first using Excel Solver just to show the shortcomings of Excel Solver. Okay, so Solver's open, and I'm going to set my objective cell to B20. That's my profit. I want to maximize my profit. And the way we're going to do that is by changing cells with the random numbers in them. I'll separate these with a column or a comma. And these cells are subject to some constraints. So this cell reference here has got to be greater than or equal to 0. And it's also got to be less than or equal to 1. Likewise, this cell's got to be greater than or equal to 0 and less than or equal to 1. So I can view all of my constraints there. That looks good. We'll use the evolutionary method and solve. Well, it's done. Solver has converged to the current solution. So this is what's wrong with Solver. I'm going to accept this solution. Is it really a surprise that the profit is maximized when we ordered 4,500 pounds or kilograms, the maximum, and we sold 4,500 kilograms? That is the maximum profit scenario. And that's really not going to help me much. I need to choose an order level based on risk and profit. So let's run a Monte Carlo simulation instead. So the Monte Carlo simulation software add-in I use is called ExcelSim 2009. It's a little bit old. It came out with Excel 2009, but it's worked on every subsequent version of Excel just fine. So let's open this up, and I think it's pretty typical of the Monte Carlo simulators I've seen. You have to designate some changing cells. So we're going to designate this cell and this cell. I'm holding down the control key. And then we get cells that we can watch and name. And the cells I'd like to watch, these are going to appear on the reporting, the report that comes back after all the trials are run. So I'd like to watch, obviously, this cell and this cell. And let's get our sales revenue, our cost of goods, our disposal revenue, and our profit. Now it's important to remember the order you did that in, because I want to name these same cells here in the report. So I'll just go down through the names, again holding the control key down. The maximum number of iterations you can do in this is 99,999. So I'm just going to choose 50,000, and we'll call this results. This will always open up a new worksheet. We'll proceed ahead. Now, you have to kind of know how this works here. This cell is highlighted, and it's asking me, how do I want the distribution of this to be? It's going to be between 0 and 1, but Do I want a normal distribution between 0 and 1, or a uniform distribution, or some other kind of distribution? And remember, this is our order amount. So just to make sure I get an equal number or roughly equal number of each order level, I'm going to make this a uniform distribution. And the lower limit is going to be 0 because we're talking about the random number here. And the upper will be 1. So there's an equal chance of any number between 0 and 1. Now it jumped down to this cell for this random number. In this case, for the produce sold, since we had kind of a somewhat normal distribution here, I'm going to subject this number to a normal distribution. And this isn't between 0 and 1. This is the mean. I'll make the mean 0.5 right in the middle, and we'll make the standard deviation 0.13 just to kind of divide it up into 8 parts. So I hit that, and you can see it's going through the trials down here in the lower left-hand corner, and this is going to take a while, so I'll report back when it's done. Okay, when it finishes up, here's the result page or worksheet that opens up. I usually get rid of these 2 rows. I normally also set all my column widths and kind of clean this up a little bit. And we don't need the trial number here. So you can see there's a number of scenarios here. Let's, just to make sure, I'm going to go ahead and copy this and paste as values to cement everything in. And let's sort this data by column A. Produce ordered. In fact, let's do a double sort. Within each of those sorts, we'll add another layer of sorting for profit. And we'll go smallest to largest there as well. So now we can start analyzing our results of all these different trials. So I've added a little summary table here I'd like to fill out. And these are just numbers in a cell. I would like to know how many trials we got for 2,000 kilograms ordered. So I'll use a COUNTIF function there. COUNTIF, and we should have this entire range. And we want anything that is equal to 2,000. So that looks about right. We'll go ahead and fix these references and paste this down. And quickly change these. So this distribution of trials looks fairly similar or appropriate given the probability here that we were assigned. Remember the probability over here, this is 15, 20, 35, and so forth. That's pretty close to what we were seeing over here. So if we open these up, they're pretty close approximations, so that worked out pretty well. One thing I did notice is I only got 30,000 trials. I think my limit on trials may actually be 30,000, a correction from what I stated before. Let's look at the average profit. We're going to use a average if function here. And you name your range to look at first. Column A, the criteria for this row is going to be equal to 2,000. And then we want to return the average in this column for the average profit. So we'll go ahead and fix these references and paste that down or autofill it. And I'll quickly go through these and change each. So the little table I've created tells me that, for example, if I ordered 3,000 kilograms of fruit. For all the trials I ran with that level of order as a given, the average profit was $11,231. Likewise, for 3,500 kilograms ordered in all of those trials, the average profit was a little less. Now, there may be some outliers within any one of these that are better than 11,000, but I think the logical conclusion is to order 3,000 kilograms because that generates the highest average profit. And over here, 3,000 kilograms is the most likely outcome in terms of demand. I hope this video has helped you understand how a Monte Carlo simulation works and how it can really help you when you have one or more random variables in play that are determining an outcome in some scenario. Monte Carlo simulations are used in many different fields for many different purposes. There is a way to do a basic Monte Carlo simulation in Excel without the benefit of a Monte Carlo simulation add-in like I have. I plan to do a video on that topic shortly. If you've enjoyed the content of this video and found it useful, please hit my subscribe button and throw me a thumbs up. Thanks for visiting Spreadsheet Geek.